Okay, screencast number 6, molecular polarity. The essential questions for the screencast. How does shape of the molecule influence the polarity of a molecule? All right, the polarity of the molecule. If a molecule overall has a slightly positive and a negative side due to the unequal sharing of the electrons, much like the water molecule is a polar molecule. Okay? And two factors are going to influence whether a molecule is polar or not. First thing is the polarity of the bonds in the molecule, and the second is the geometry of the molecule. How do those polar bonds cancel each other out, or do they add together? Okay, so in your notes, draw the structure of the four examples, determine their shape, and we're going to determine if the bonds are polar or nonpolar. So at this point, you should be able to draw the Lewis structure. You should be able to determine the shape of the molecule. The only thing we're adding in this screencast is whether the bonds are polar. Oh no, you can do that too. Whether the bonds are polar or nonpolar. What we're going to add is whether the molecule is polar or nonpolar. So pause the screencast, draw the structures, determine the shape, and what bonds are polar, what bonds are nonpolar. Okay, so let's look at that example number 1. You should have this drawn in your notebook. All right, CH3Cl. If we look at this molecule, all of these bonds are polar. Okay, it is a tetrahedral shape because there are 4 electron domains about that center atom. The CCl bond is polar, the CH bond is polar. If you look at the polarity though, this bond, the hydrogen is going to be positive, partially positive, with the electrons going towards the central carbon atom. Between carbon and chlorine, however, chlorine is going to be more electronegative, so the electron cloud is going to go that way. In this drawing, this maybe we'll draw this one. This should be a different color representing the chlorine. Okay, these polar bonds do not cancel each other out. Hopefully you can see that overall the molecule is going to be polar with the partially negative end on that chlorine, partially positive on all of those hydrogens. Okay, so polar molecule because the bonds are polar and those bonds kind of add together to make one end of the molecule more negative than the other. Now let's look at the carbon tetrachloride molecule. Again, 4 electron domains. 4 electron domains. Okay, going to orient themselves so that they're as far apart as they can be, so that's tetrahedral. Are these polar bonds? Polar bonds? Yes, they are. Okay. Again, the carbon is going to be the slightly positive, with all of these bonds, do that kind of wrong, all of these bonds being partially negative where the chlorines are, and the carbon will be partially positive. Now, because of the orientation of these, and all of these bonds are identical, okay, those polar bonds kind of cancel each other out and make the molecule nonpolar. So what you have is symmetry of that molecule. Those polar bonds, they are unequal sharing, but they're unequal sharing equally across the molecule, which makes the molecule nonpolar. So the bonds are polar, but the molecule overall is not polar. Okay. NH3, ammonia. In this case, the hydrogens are going to be partially positive with these polar bonds. They're polar because they're not the same atom. Okay. They're all drawing that unequal sharing to the nitrogen. Now, there are 3 polar, but remember, what is this shape? It's a trigonal pyramidal. Okay, that lone pair of electrons on this nitrogen, okay, making these hydrogen bonds go off that plane. So it's a trigonal pyramidal shape. So even though I have polar bonds and they're all going towards that central nitrogen, because they're not in the same plane, they do not cancel each other. They add together, making the molecule polar. And two, nonpolar bonds, nonpolar molecule, it's a linear molecule,